Hey guys, so welcome back yet again. This video is literally gonna be like the quickest video ever. So, relative and absolute configuration. So it's just different configurations that you could find your molecule in. So here is E and here is Z, right? And if you haven't seen this before, you're probably asking, oh, what does this mean? So this is going to be what you find about these configurations, relative and absolute, is a lot of it is going to have to do with priority groups. So Z, what my teacher used to always tell us, was that Z was like same side, which really means same side. So if both of your highest priority groups are on the same side, it's Z. So do you see how here this ethyl group and this chlorine group both take priority over the CH3 group and this hydrogen because these two are on the same side. It's going to be Z. Now, E is pretty much just the opposite of that. So you see here how E, um, the priority group, the bromine, is on this side. When if the bromine was on this side with this group here, um, then it would be on the same side as this big group. But because the bromine isn't on that side and the bromine is here away from the bigger group, then it's going to be E. So pretty much what you need to know about this is Z is when the two big groups are on the same side, and E is when the two big groups are on opposite sides. And done. So next is R and S. So again, this is the same thing as priority. So your steps of R and S is step one, you number your carbons. Step one, you number your groups in terms of priority. And just to go over, when I say priority, I'm talking about atomic number. So you order your groups in terms of highest atomic number, okay? And then you check which way it's going. So if we go this way, we see that's counterclockwise. So we would say that this carbon is going to be S. Okay, and that's because it's counterclockwise. Um, if it was clockwise, it would be R. A few things to know. Well, one really big thing to know about this is that your lowest priority group should be on a dash. Um, Lowest priority group needs to be on a dash. Okay, so what I mean by that is this carbon is technically number four. Um, And so whatever is ranked as your lowest group should be on a dash. And when it's not a dash, let's say it's like a wedge, it would like change the stereochemistry. So like let's say we put something like okay. And again we're gonna number it based on highest priority. So one, two, three. So do you see how this is R? But because this group isn't on a dash, we're going to say looks like R. But it's actually S. So that's the main difference. I mean, that's like the key thing that you need to know. Um, because I've actually seen this a lot. I will say this is like they do this all the time, especially in New World. Um, so when your lowest priority group isn't on a dash, it's the opposite of what it looks like. So in this case, it is, again, it is clockwise. Clockwise will tell us R, but because this hydrogen, being our lowest priority group, is not on a dash, we have to rotate the molecule. So it looks like R, but it's S. Awesome. I hope that made sense. And last thing that I will say about this is your lowest priority group isn't always going to be an oxygen. I mean, the lowest priority group isn't always going to be a hydrogen. So just take note of that. Fisher projection, this one will be really quickly. So you will see, especially you're going to see this a lot with carbohydrates. So I don't know, let's draw. So like a lot of times you see it in biochem, like, okay, I was about to draw glucose, but I don't care enough. But a lot of times you'll see this in biochem and less of just orgo in terms of the MCAT. But all I really want you guys to know is when you see this structure, you should imagine it like this. So if it's on a line, it's gonna be dashed. Okay. So they're all on lines. If it's on a vertical line, it's gonna be dashed, and if it's on a horizontal line, it's gonna be wedge. Okay. So that's pretty much what you need to know about Fisher. And if you haven't seen it before, there is a carbon here. So your Fisher projection is gonna look, if I want to put this in regular, it would be a carbon with a Br, with a CH3, with a H, with a Cl. And if I want to put this in bond line, Cl, Br, H. Okay, so all of these are the same thing. Okay, so those are the different configurations that you can have. And yeah, so that's it for this video. As you can see here, we are going on. We're going to skip chapter 3. Pretty much chapter 3 actually isn't very important to organic chemistry. And we're going to go over that when I do Gen Chem anyways. So we're going to go chapter 4 and acid and base. So I'll see you in chapter 4.